In this video we're going to take a look at K.2, K.3, and K.15 under polynomials. I'm going to go ahead and start with add and subtract polynomials. And as always, if you need some help, you can either just type in something wrong or learn with an example are a great place to start. Now these ones you'll notice have parentheses, and this one has subtraction in between. So I'm going to take the like terms. In this case, the 9s and the 2s are like terms, but I need to subtract them. So 9 minus 2 is 7s. 1 minus 1 is 0, so you can put plus 0, but you don't have to. Okay, now with plus, the parentheses aren't quite as important. We can just eliminate them. I'm just going to go with like terms. So starting with the highest exponent, I have a 4x squared. There's nothing else like that. Oops, I'll type the x first and then hit this key here for the squared. Hit the right arrow to get out of it. Now I have a 6x and a 6x. I'll add those together to make 12x. I have a 6 and a 2. I'll add those together to make an 8. Similar problem here to the first one. I'm going to go back to K.3. Multiply polynomials. A lot of the time when we're multiplying polynomials, I want to think about it just in terms of distribution. Now this particular one is just two things being multiplied. So I'm going to do signs, numbers, and then variables. So for signs, I have a negative times a negative is a positive. You don't have to put a positive sign. I have 2 times 4 is 8. And y to the 4th times y squared, I'm going to add the exponents together. It's going to make y to the power of 6. Okay, here I'm going to distribute. So I'm going to multiply the 8 to the negative 4a squared and the 8 to the negative 1. So I get a negative 32 a squared, hit the right arrow key to get out, minus 8. Okay, with signs I have a negative. No number there means it's a 1. 1 times 7 is 7. And I'm going to add the exponents. F to the power of 3 times f to the power of 3. 3 plus 3 is 6. Alright, let's take a look at K.15. Domain and range of polynomials. Now domain is left and right. So if I look at this polynomial, it doesn't ever have a leftmost point where it stops. It continues forever. It goes up, but it also goes left forever. And it goes down and right forever. So there's no boundary left and right. So the correct domain is negative infinity to infinity for left and right. It's actually the same for the range because it goes up forever and down forever. There's no minimum or maximum value. Okay, now this one does have a minimum value, no maximum. There's no leftmost or rightmost value. So if I start with domain, domain is not limited in any way. It's negative infinity to infinity. Okay, now for range, we have a lowest point right here, and if we follow that over, that's negative 5. So it's negative 5 up to positive infinity. So I just have to be careful I get the right one, negative 5 and not positive 5. The square bracket indicates that it includes that point at negative 5. Alright, very similar here. Left and right goes forever, but I have a maximum point at 7. So here's my domain. Now the maximum point at 7 right here, make sure we get the positive 7 and not the negative 7. Okay. This one has a relative minimum and a relative maximum, but I need this global maximum here when I do domain and range. So domain is still left and right forever, and it went up to a highest of 6 there. Now it indicates that the absolute maximum is shown on the graph, so there's no other place where it comes back up higher than that. So 6 is the highest. Okay, if you have more questions, please email me. Good luck.